Hi, welcome to Sachin Study Tech. Today topic is Prim's algorithm by using greedy method. So here you can find out the minimum cost spanning tree by using Prim's algorithm. Prim's algorithm is a greedy algorithm like Kruskal algorithm. This algorithm always starts with a single node and move through several adjacent nodes in order to explore all of the connected edges along the way. So this is the algorithm. Three steps is there. Step 1, select any connected vertex with a minimum weight, and with minimum weight here select unvisited vertex which is adjacent of already visited vertex with a minimum weight, and repeat step 2 until all vertices are visited. Now you can see, already minimum cost spanning tree, the span that graph will not consider any loop and parallel edges. If it is there, you can remove that one, and also you can apply. These are the steps. Now we can discuss. This is the example problem here. It is a loop is there. Here you can loop, self loop, you can remove it here also parallel edge is also there, a to b 6 and 9, so you can remove maximum edge. Here it is 9, you can remove it, you can keep it minimum weight or minimum cost of that edge. So here it is vertex S and A, here it is vertex C, here it is vertex D. For example, here it is vertex B, here it is vertex T. So these are the number of vertices. What is the first step? First step means which having the minimum cost. So here the loop is discarded, and parallel edge also can remove it. Then here either B to D or D to T. You can consider any one of these. So for example, I am consider B to D. B to D. You can consider these two vertices. The cost is 2. Next minimum cost is D2 D2T. Here it is D2T. Already this is the already visited vertex. That's why already visited vertex, D is already visited vertex. That's why you can take the adjacent of already visited vertices. So next one is already, you can take these two edges. Then next least cost is C to D and A to C. For example, I am consider A to C. If you cannot take this A to C, because already what are the visited vertices is there, you can take the adjacent of that visited vertices. So that's why I am consider the C to D here, C to D. So I am consider C to D. The cost is now it is a 3. Next cost is C to B. C to B, already B is a visited vertex. Okay, you can take it C to B, but here if you can take this C to B, it form a cycle, so you cannot consider that one. You cannot consider this edge. You cannot consider that one. Now we can take next least edge is B to T. If we can take the B to T, it is also form a cycle. So spanning tree will not contain any cycle. That's why we cannot consider this edge is also. Now we can take the next cost, next least cost here. Already you know C is already is there here, A to C. If we can take the A to C, already C is the visited vertex, that's why we can take this edge. Okay, the cost is 3. Now here it is, next least cost is, already can consider this one. Next least cost is, that is 6 is there, 7 and 8 is there. So this is the least cost, A to B. If you can take the A to B, it form a cycle. That's why you cannot consider this edge. And next one is S to A. That is, here it is 7. Next least this S to C. If you can take S to C, it form a cycle. That's why we can ignore this edge. So this is a minimum cost spanning tree by using Prim's algorithm. So here you can see, first you can see that B to D. So B is the visited vertex. You can note down that B is the visited vertex. Remaining vertices, what are the remaining vertices? You can list out those remaining vertices. Then what are the adjacent of already visited vertex is there. You can take it one by one, and you can change the remaining vertices, and you can add that. So this is the Prim's algorithm. It is a minimum cost spanning tree. What is the minimum cost here? It is a 7 plus 3, 10 plus 3, 13 plus 2, that is 15, plus this is a D to T is 2. 15 plus 2, 17. 13, 15, 17. The minimum cost is 17. So how many number of spanning trees are possible for this? So here also you can see this is a one edge, 1 and 2, 3. Here it is a 4 and 5, 6, 7, 8, 9 edges is there. 9 edges, 9 minus how many edges you can remove? How many vertices is there? Here it is 6 vertices is there, 6 vertex plus 1, that is equal to so 4, that is equal to 4. So 4 edges you can remove it. So here you can see this one and this one and this one and this one, 4 edges you can remove, it is form a spanning tree. So how many number of spanning trees are possible for this graph is NCR. So what is the n is the number of vertices of this graph, that is 6. What is the r is a 4, 6c4, that is equal to 6 factorial by 6 minus 4, that is 2 factorial into 4 factorial, that is equal to 6 factorial means 6 into 5 into 4 factorial by 2 factorial is 2 into 1, that is 2 into 4 factorial. So 4 factorial cancel. Here it is 3, 3 into 6, that is 3 times it can cancel. So it is a 15 spanning trees are possible. 15 spanning trees are possible. Out of that 15 spanning tree, so this is the minimum cost. Maybe more than one is same spanning tree is also possible. And also you can see what are the number of vertices is there in the original graph. That number of vertices must be there in the any spanning tree. So for example, this spanning tree consisting of 6 vertices, all other spanning tree also consisting of same number of vertices. So thank you for watching this video.